Okay, welcome back. This is our third snow day video on simplifying radical expressions. And today we are going to actually multiply and divide radical expressions together. And after we multiply and divide, we will then add and subtract. And remember, when we multiply and divide, we glue things together. Okay, when we add and subtract, something must match. Okay, so let's look at the first example. The homework is written on the board, just two questions for this video. Okay, number one, we're looking at 2 times the fourth root. And be careful, this 2 is multiplied out front. This is the index 4. Okay, so the 3 is multiplied out front. This is an index of 3. Okay, the 5 is multiplied out front. The index of the root is a 2. Remember, square root, the index of 2 is unwritten. So this is index of 2. So 2, fourth root, the index is 4, of 3, x to the third, y squared, multiplied by 3 times the fourth root of 27 xy squared. And think of it like this. Radicals, we can glue them together, just like we do with monomials. We can glue all of this together. You multiply your number by your number. 2 times 3 gives what? 6. So on this problem here, you will multiply your numbers together. Your 3 times your 2, and you will get a 6 out front. Now, we're going to have fourth root multiplied by fourth root. We're going to multiply what's underneath by what's underneath. So multiply the radicand by the radicand. Remember, we're looking at, this is the radicand underneath, and outside is the index. Okay, so the little number here is the index. So our radicand is 3x cubed y squared, and the index is 4. Okay, so we're just looking at radicand multiplied by radicand. So multiply these together. 27 times 3 gets multiplied together. 3 times 27 gives 81. Okay, so write 81 x cubed times x. We're adding exponents. 3x is multiplied by 1 more x gives x to the fourth. And y squared times y squared, 2 plus 2 gives y to the fourth. And now, after you combine, you then have to simplify your radical by taking out groups. Again, looking at, after the last video, we learned the concept of taking out groups of what? Groups of 4. So we're going to take out groups of 4. Before you do this, you have to take your 81 and break it down. So take 81 and divide by either 2, 3, 5, 7, or sometimes 11. Okay? 81 is what? 3 times 27. Okay, we divide 81 by 3, we get 27. And some students just write 9 times 9. That's fine. Okay, 27 is 3 times 9. Divide the 9 by 3, we get what? 3 times 3. Some students like to just say 81 is 9 times 9, which is fine. And divide 9 by 3, we get what? 3 times 3. 9 is 3 times 3. So how many 3's multiply to give 81? Hopefully you say there are 4 3's that multiply to give 81. So we're going to replace this 81. This is the fourth root of 81 is going to be replaced by 3 to the fourth power. So 3 to the fourth, x to the fourth, y to the fourth. And what's sitting outside? We already have a 6 outside. Okay, so put your 6 outside. Now, after you've broken down your number, after you've broken down your 81, okay, now we're going to take out groups of what? Groups of 4. Okay, groups of 4. Can we take a group of 4 3's? Yes. Okay, so we can take one group. How many groups? One group of 4 3's. Remember, every group comes on the outside and becomes a single number on the outside. Since we have one group of 4 3's, we're going to take this out. It's going to become one single 3 on the outside. And what are we going to do with the 3 that comes out and the 6 that's already out here? We're going to multiply these and get 18. If you're having a hard time seeing this, remember 3 to the fourth is 3 times 3 times 3 times 3. We circle a group of 4 3's, and the group of 4 3's comes out and becomes a single 3. Okay? All right, now, to the group of 4 x's. Okay, the group of 4 x's, we're circling one group of 4 x's. A group of 4 x's comes out and becomes what? A single x. So we're going to have an x on the outside. All right, now, if you're having a hard time seeing this again, we have 4 x's. We circle a group of 4 x's. What comes out? The group represents a single x on the outside. Okay, so just circling it again. And lastly, we have, I think you can just obviously see this, we have a group of 4 y's. Circle one group of 4 y's, comes out, becomes what? Becomes a y. So we have what's on the outside? A y. Now the question is, what's left underneath the root? Well, we took out 4 3's, we took out 4 x's, and we took out 4 y's. There's nothing left under the root. There's nothing left under the root. Or I should say, when we say nothing, it's the same thing as when we were dealing with multiplication rules. There's a 1 left. Okay, so we don't write this. The fourth root of 1 is 1, and we just ignore it. So if everything comes out, we don't write the radical, and this is your final answer. But believe it or not, this is a wrong final answer, and I'm not going to get into the details right now. This is supposed to be absolute value of y. Remember, even 4 divided by an even 4, even divided by even gives 1. We have absolute value. You're saying, wait a minute, if you have absolute value around the y, why don't you have absolute value around the x? Ugh, long discussion here, guys, and I'm not going to get into it in the video, but I just want you to just know I'm not worried about this right now. I'm not worried about the absolute value case right now necessarily. Okay, but the absolute value goes around the y in this case and not the x, and I will try to discuss this when you guys get back. For this problem, you don't have to worry about absolute value because your index is what? Your index is odd. Remember, we only worry about absolute value when we have an even index, like 4. So 4th root, 6th root, or square root, because square root, the index, is an unwritten 2. Okay, so we only worry about absolute value when we have an even index. All right, if you have an odd index, like 3, you do not have to worry about absolute value. So this is your final answer. Okay, so we glue it all together and then take out groups. All right, next problem. So again, multiplication is like glue. You just glue everything together, guys. Now, addition changes things. Addition, remember, addition and subtraction is a little more difficult. Okay, rules are more complicated when we deal with addition and subtraction. Next problem, we're looking at 9 root 12 plus, notice the addition, plus 5 root 32 minus the square root of 72. Now, my question is this. What is the root of 2 multiplied by the root of 3? Can we multiply radicals together? Yes. You can multiply radicals together and get the root of 6. This is correct. You can multiply or glue radicals together. However, what is the root of 2 plus the root of 3? Can we add radicals together? Can we add radicals together and get the root of 5? Question mark. Okay, no. This is completely wrong. You cannot add radicals together. So, can we multiply the radicands 2 times 3 and get a root 6? Yes. Can we add 2 and 3 and get root 5? No. Let me show you. I think this will make sense. Okay, so if I asked you the root of 4 multiplied by the root of 9, is this equal to the root? Can we take the radicands and multiply them together? Yes. 4 times 9 gives 36. What is the root of 36? The root of 36 is 6. What is the square root of 9? That is what? 3. And what is the square root of 4? That is what? 2. Is 2 times 3 equal to 6? Yes, that's true. So can we multiply radicands together or radicals together? Yes. What about root of 4 plus root of 9? Can we add 4 and 9 and get the root of 13? No, this is completely false. Look, the root of 4 is 2. The root of 9 is 3. Is 2 plus 3 equal to the root of 13? No. 2 plus 3 is 5, which is the same as the root of 25. Okay, root of 25 is 5. This is wrong. So question, can we add radicals together? No, you are stuck. Okay, you're stuck at this point. Already simplified. Okay, or maybe we should just write simplified. All right, this is already simplified. Now, we can multiply. So in the last problem, we glued them together through multiplication, but with the addition, you cannot. So my question here is, can you add root of 12 plus the root of 2 and get the root of 44? Absolutely not. You cannot add these together. Okay, so instead, we simplify our radicals, and in the end, after we simplify them, if something matches, we can combine under addition, and what matches won't change. Let's start. Take the 12 and break it down. So we have to break down the 12. Let's see. 12 is what? 2 times 6, which is, well, 6 is 2 times 3. So we have 9 times what? The square root of how many 2's multiply to give 12? Hopefully you say 2 2's. So 2 squared and an extra 3. Now, let's break down the 32. So breaking down 32, we get what? 2 times 16. 32 is 2 times 16. Divide by 2 again. 2 times 8. 16 is 2 times 8. Divide the 8 by 2. 2 times 4. and 4 is 2 times 2. How many 2's multiply to give 32? You should start to memorize this the more you do this. 1, 2, 3, 4, 5 2's. So we're going to write this as 5 square root, not 32, but how many 2's multiply to give 32? There are 5 2's. So 2 to the 5th. And now 72. Break 72 down. 72 is what? 2 times 36. Okay, divide by 2, you get 36. 36 is 2 times 18. Okay, break the 18 down, which is 2 times 9. Break the 9 down, which is 3 times 3. So how many 2's multiply to give 72? 1, 2, 3. So we're going to write this minus the square root of 1, 2, 3 2's is 2 to the 3rd. And how many 3's? There are 2 3's, so 3 squared. Now, we're taking out pairs. Remember, when you have cubed root, or fourth root means take out groups of 4. Cubed root means what? Cubed root means take out groups of 3. Square root, the index is unwritten. Okay, the index is an unwritten 2. So we're taking out what? Groups of 2 or pairs. We're taking out pairs. Okay, so our index here, which is unwritten, is a 2. And notice on the problem given tonight, your index is a 2, so you will be taking out pairs. There's no index written, so your index is an assumed 2. Taking out pairs. My question is, can we take out a pair on the first radical? Yes. Can we take out a pair of 2's? Yes. Look, 2 squared times 3 is 2 times 2 times 3. So can we take out a pair of 2's? Yes. We can take out one pair of 2's. Remember, every pair or every group becomes a single on the outside. So a pair of 2's comes out, becomes what? A single 2. And what do we do with the 2 and the 9 that are already out here? We multiply them. 2 times 9 gives 18. And what's left under the root? Well, my question is, can we take a pair of 3's? No, there is only one 3, so you're left with a 3 underneath. Now, on the next, can we take out pairs? Yes, you have 5 2's. How many pairs of 2 are there? How many pairs are there in 5? If I write 2 times 2 times 2 times 2 times 2, how many 2's do you have? You have 5. We're circling pairs. We're circling pairs. Okay, so how many pairs are there in 5? There are 2 pairs. If I said go to the next number below 5 that's divisible by 2. Since we're circling groups of 2, we're dividing by 2. Okay, what's the next number below 5 that's divisible by 2? That's 4. And what is 4 divided by 2? What is 4 divided by 2? Well, that gives 2 groups. 2 groups. So we're circling pairs. Okay, we circle pairs. How many pairs are there in 5? There are 2 pairs in 5. Remember, every group comes out, becomes a single. So this pair of 2's comes out, becomes a 2. This pair of 2's comes out, becomes a 2. And what do we do with the 2? The 2 and the 5 that are already out here. We multiply them together. 2 times 2 is 4. 4 times 5 is 20. So we get plus 20. And what's left under the root? Notice we did not circle this extra 2. This extra 2 is left. Now, can we take out pairs on the last one? Put your subtraction, minus. Can we take a pair of 2's? Yes. If you write it out like this, 2 times 2 times 2 times 3 times 3. Can we take a pair of 2's? Yes. How many pairs? One pair of 2's. So how many 2's on the outside? Well, we have 1 2 on the outside. Can we take a pair of 3's? Yes, we can take one pair of 3's. So how many 3's on the outside? Well, we're going to have a 3. So we're going to have a 2 and a 3. And what are we going to do with these? We're going to multiply them together. Not add. You are multiplying. 2 times 3 gives what? 2 times 3 gives 6. So the pair of 2's became a 2. The pair of 3's became a 3. We multiply them, we get 6. And what's left under the root? What's left? Well, you have an extra 2. So there's an extra 2 left. And that stays under the radical. Now, we are done taking out groups. Now we look. When we add, something must what? Add or subtract. When we add, something must match. And what matches doesn't change. Okay, so does something match here? We're looking at the radicals. Well, does root 3 match anything? No. But notice, you have a root 2 and a root 2. What matches doesn't change. So write your root 2. And add what's in front. We have a positive 20 and a negative 6. 20 minus 6 gives 14. So we get 14 root 2. Cross these two terms out. And what else do we have? We have a positive 18 root 3. Positive 18 root 3 stays alone, stays because nothing matches. It just stays the same. And we have a positive 14 root 2, so plus 14 root 2, and you're done. Okay, so we're done because we had something that matched, and what matches doesn't change. We add these together. The root 2 does not change. 20 minus 6 is 14. Very similar to what we've done before. Now, one more quick example. Looking at 3 square root of 90 plus 4 square root of 20. If you've got it, go ahead and stop the video and get these two problems done. But if you need to see another example, I'm going to put one more up here. Plus the root of 162. So we take each number and break it down. Remember, you cannot add 90 and 20 and get 110. We cannot add what's underneath the radical. Okay, so we take this 90 and break it down. 90 is what? 90 is 9. I'm just going to do this. 9 times 10, which seems easy. 9 is 3 times 3. 10 is 2 times 5. So we get what? 3 square root of, we have 1, 2. We have 2 3's, so 3 squared, and we have an extra 5. So we have a 5. Plus 4, now break down 20. 20 is what? 2 times 10, which is 2 times 5. We have 2 2's, so 2 squared times what? A 5. And now break down the 162. This is a monster. Okay, so take 162, break it down. 162 is 2. Since it's even, divide by 2, we get 81. 81 is what? 9 times 9. Break this down. 9 is what? 3 times 3. 3 times 3. So how many 3's? There's 4 3's and an extra 2. So we have the square root of what? A 2. And how many 3's? 1, 2, 3, 4 3's. So 3 to the 4th, and put your addition. Now, take out pairs. Take out pairs. Why are we taking out pairs? Because square root has an index of what? An unwritten 2. So we're taking out groups of 2 or pairs. Question. Can we take a pair of 2's? No, there's only 1 2, so leave it alone. Can we take out a pair of 3's? Yes. How many pairs of 3? Well, there's only 2 3's. Okay, so we can take out 1 pair of 3's, and this every pair becomes 1 on the outside. Since we have 1 pair coming out, we're going to have a 3 on the outside. And what happens with the 3 and the 3 that's already out here? We multiply them together, we get what? 9. Can we take a pair of 5's? No. 5 is left because we only have 1 5. What's left under the root? Well, we took out all the 3's. We took out, here, 3 times 3, we took out the entire pair. The entire pair came out, became a 3. What's left? There's a 2 and a 5. Multiply those back together, we get a 10. Now, on the next, can we take a pair of 2's? Yes. 1 pair of 2's comes out, becomes what? A 2. Take the 2 and multiply by the 4 that's already out there, you get what? An 8. And what's left under the root? We have an extra 5 that's left. Why not any 2's? Because we took out the whole pair. The whole pair of 2's came out, became a 2. Now, on the last one, can we take a pair of 2's? No. But can we take pairs of 3? Yes. How many pairs? Hopefully you can see now that there are 4 3's. And how many pairs are there in 4? Well, think about taking the exponent 4. Take the exponent 4 and divide by 2. This is the better way to do it. Take the exponent 4, divide by 2, we get what? 4 divided by 2 is 2. So we get an exponent of 2. We get 3 squared on the outside. Why did the 3 to the 4th become 3 squared? Because we took the exponent 4 and divided by 2, we got a 2. You can also think of this as groups. Okay, 3 times 3 times 3 times 3, we take a pair of 3's, comes out what? Becomes a 3. We take a pair of 3's, it comes out, becomes what? A 3. We multiply the 3 and the 3 together. That's the same as 3 squared, which is what? 9. And what's left under the root? We have an extra 2. Now, are we done taking groups out of the roots? Yes. Now look. Now we are adding. When we add, something must match. Does anything match root 10? We're looking for radicals that match. No. Nothing matches root 10 because we have a root 5 and a root 2. Does anything match root 5? No. Does anything match root 2? No. Since nothing matches, there's nothing you can do. This problem is already what? Already simplified. Okay, so we are done. If nothing matches, you cannot add it together, and that concludes this video.